Okay, class, today we're going to look at solving one-step equations. But before we do that, we need to talk about some vocabulary. There are 4 vocabulary words that you need to know when you're talking about equations. The first one is variable. And a variable is a quantity or a function that may assume any given value or set of values. We typically use x, y, and z, or a, b, and c, some letter to represent our variable. And its value can change. As it says in variable, it can vary. Then we have constant. A constant is a value that does not or cannot change or vary. It will stay the same today, tomorrow, next year. It will always stay the same. Expression or algebraic expression. It is a symbol or a combination of symbols used in algebra containing one or more numbers, variables, and arithmetic operations. And then last but not least, an equation. 2 expressions that are said to be equal to each other. So one thing equaling another. It's going to be what we call an equation because it's got the equal sign. Now, I've got one question for you. When did you begin solving equations? Well, to be real honest, all the way back in kindergarten and first grade when you had problems that looked like this. 4 plus box equals 7. And I asked you to fill the box. What we're looking for is we're looking for a missing value in this particular problem. And we know that the value or the answer to this particular problem would be 3. Okay? But we could also have a problem that may look like this. Okay? 9 plus box equals 10. Where now, same box, but it's going to have a different value. Because in this particular problem, the number I'm looking for, the answer I'm looking for is 1. So that answer in that box or that variable, it can vary. Now today what we're going to look at is solving one-step equations. But before we can solve those, I want you to see where you're headed. When you're solving one-step equations with addition and subtraction, it is the very basics of algebra and solving equations. Okay? And you have to learn to, as the old saying goes, you have to learn to crawl before you can run. And after you crawl, you learn to walk. And there are many steps in between the crawling stage and the running stage. And that's what I want to show you. Okay? What would it look like if I wanted to run? Well, here's an equation that we will have next semester. It says, what do I have to do in order to solve the equation this particular way? Well, what we're going to do in this one, this is where we're headed. Okay? So I'm going to just do this really fast. And you just kind of watch and see what happens. And then we'll take a step backwards and learn how to solve the very beginning steps, one-step equations. So in this one right here, what I would do is I would take this 2 and I would distribute it out to the 2x plus 5, which means I would get 4x plus 10. And that's equal to, take this 3 and distribute it out to the 3x minus 4 or plus negative 4. And we end up with 9x plus negative 12. Now the goal to every equation is to find the value of x. And in order to do that, I need to get my x's all on one side. So I'm going to move this 9x to be with this 4x. So I will write 4x plus negative 9x plus 10 equals 9x plus negative 9x plus negative 12. So then I evaluate this, or I simplify it, and I end up with negative 5x plus 10 equals negative 12, because my 9x's will cancel out. Now I need to get the 10 over to be with the negative 12. So negative 5x plus 10 plus negative 10 equals negative 12 plus negative 10. So 5x, or negative 5x, is equal to negative 22. Now, our whole goal is to get the x by itself. So I divide both sides by negative 5. And I end up with x equaling positive 22 over 5. That's where we're headed. So by the end of this year, you should be able to solve this same problem. So let's take a step back. Let's look at one a little more simple. X plus 6 equals negative 12. Now our whole goal or whole process is to get this letter by itself. But what you saw me do in this previous one, in order to get rid of this 6 or to move this 6 over to be with the negative 12, what we do is a process called add the opposite. That's all we're going to do. We're going to add the opposite. So we're going to take this x right here and this x plus 6. We're going to do x plus 6 plus negative 6 equals negative 12. Because my goal is to get the x by itself, so I need to make this 6 go away. And the only way I can do that is to turn this 6 into a 0. And the way we do that is we add its opposite. But just like in fractions, we have the golden rule in math that says what you do to one, you must do to the other. So if I add a negative 6 on this side into the problem, I have to also add a negative 6 on this side of the problem as well. So now, what happens is I simplify the problem. So these 6's will go away, and I'm left with x on this side. And on the right-hand side, I end up with negative 12 plus negative 6. Well, we know in addition that if our signs are alike, we add them and keep the sign. So we end up with negative 18. So if I were to take this negative 18 and plug it back into the original equation, negative 18 plus 6, that should make this a true statement. And it does. Negative 18 plus positive 6 does give us negative 12. So the process that we use to solve equations with simple one-step equations is we add the opposite. That's what I want you to remember. Add the opposite. Let's try another one. Now we have m minus 8 equals 4. Well, when we worked with integers, what did we do with a minus sign? What did we do with this minus? We changed it. So we're going to change this minus to a plus and the 8 to its opposite. Now we're going to do exactly what we did in this previous problem. My goal is to get the m by itself, so I need to get rid of the negative 8, or I need to move it away or turn it to a 0. And the way we do that is we add its opposite. So we'll do m plus negative 8 plus 8 equals 4. Now if I added an 8 on one side, I need to add the same 8 on the other side. So we end up with, now that we simplify this expression here, this equation, my 8's will cancel each other out and turn to 0. And we're left with m is equal to, and now 4 plus 8 gives us 12. So if we were to take that and check it, if we go back to the original problem that it was, we have 12 minus 8. Does that give me the answer of 4? And yes, it does. And that tells me that this is the correct answer. So again, to solve any equation with addition or subtraction, we're going to add its opposite. Let's try another one. Now what's different about this one? Well, the letter's on the other side. But we still do the same exact thing. I still need to get this letter by itself. Now one thing that you can do if you want to, I'd rather you not, because eventually, as you saw in that big problem, you had letters on both sides. You can flip-flop this. You can take this g plus 7, put it on the other side, and put the 10 over on the right, because, by the way, both sides are equal to each other. So we could write this as g plus 7 equals 10, and it still give us the same answer. But I'm going to work this one to show you what you can do with one on the other side. So now I just start on the side with equals. So I still need to get rid of that 7. And how do we do that? We add its opposite. So g plus 7 plus negative 7. There's the opposite. So this is what I have to add on the other side. So I just move over a little bit and put the 10 plus the new thing, negative 7. Now we just simplify. 10 and negative 7 make 3 equals, my 7's disappear, and I'm left with 3 is equal to g, or g is equal to 3, whichever other way you want to write it. And if we were to plug that back in, 10 equals 3 plus 7, that is a true statement. Let's try one more, and then we'll be done. So we've got t plus negative 5 equals negative 14. These parentheses don't mean anything other than this number is negative. So I need to get t by itself, so I need to get rid of this negative 5. So how do we do that? We add its opposite. T plus negative 5 plus, and the opposite of negative 5 is 5. So this is the new thing, equals negative 14 plus 5. And again, sometimes it helps if you underline the new thing so that you make sure that it's on both sides. Now I simplify this line. My negative 5's go away, and I'm left with t equaling. And then negative 14 plus positive 5. My signs are different, so we subtract, and we end up with negative 9. So if we were to plug this back in, negative 9 plus negative 5, does that give me negative 14? And yes, it does. So to solve equations, what we do, our goal is to get the letter by itself. So whatever is with it, I need to get rid of it. And we do that by turning it to a 0 or adding its opposite. And if you add its opposite to one side, you have to add its opposite to the other.